Yes. Now after that, how would we calculate for errors? Calculation for errors. Now, most times when you're calculating for errors, it is always very simple. When you're calculating for errors, it's always very simple. Whereby you just come and say, they can tell you that a given number A, which is 2.7124, is rounded off to give. So this number A is rounded off to give, meaning that they rounded off this to give a number B, which is 2.7. So they rounded off this to get this. Then they can tell you to calculate the error in that, or calculate the error made. So the thing is very simple. Remember what we said that error? We said that error is the difference between the actual and the approximated. So when you get the difference between those two, you'll be getting what we call an error. So what was our actual? Yes, I know. You've been following. So what we call an actual is the first value that we have before rounding off. So approximated is the one that comes after rounding off. So what was our number before rounding off? Yes, they said A is rounded off, meaning that this one is the one that is rounded, meaning that it's the actual. So where there is actual, I put this, which is 2.7124 minus approximated. How do you get the approximated? We said approximated is the value that is got either after rounding off or after truncating. So this one is rounded off to give, meaning that after rounding off, we got 2.7. I think you see this one has very many decimal places and this one has a few, meaning that this one was the actual one before rounding off, then this one is the second one after rounding off. So you're going to say minus 2.7. So the answer that you get will be the error. This one minus this one, you're going to get 0.0124. So that's what we call our error. Yes, you're following. Now in errors, we have different, we call them terminologies, or what we call terms. And the first term is what we call absolute error. Yes, the error can be there, but there is what we call absolute error. And absolute error is just the magnitude of the error. So they are meaning that after getting your error, you come and get its magnitude. Magnitude means that you take the positivity, even if your error has been a negative answer, so we take the positive of it. You getting me? So what was our error? So we have got the error here above, following what we did, but now we want to get absolute error. So on the word error, we are adding the word absolute. By the way, most times you always write it as this, E-abs. This one means error absolute. So what you do, you just get the error, but you get its magnitude. So our absolute error is going to be the magnitude of the error. But what was the error? 0.0124. Magnitude of something means that you take its positive. If this one was negative, so our absolute error would be positive. And magnitude of this remains 0.124. So what if our error was a different one? If the error was, for instance, if the error was negative, maybe, for instance, for instance, if our error was negative 0.005 and they tell me to calculate absolute error. Remember, we have said that absolute error is the same as magnitude of the error. So it means that we shall have magnitude of our error, but our error is 0.005, but it was negative. So when I say absolute, I am meaning that even if it was negative, then you write the positive of it. That's what we call absolute. And the answer would be 0.005, ignoring the negative, because that's what we call absolute. You're getting me? So now, let us go to other terminologies. For example, relative error. So the first one was absolute error. So we are using the same work. Now we are going to do what we call relative error. So what is relative error? Relative error is got by getting the error, absolute error, but you divide it by the actual. Relative comes from the word relates. So when you are relating, most times we are trying to relate two things. So we are relating our absolute error with the actual value. So the answer that you get will be the relative error. And what was our absolute error? Our absolute error is this. Remember, we said that absolute error is the magnitude of the error. This was the error. So this is our absolute what? Error, you remember. So we are going to say relative error is absolute, which was 0.124 out of actual. Our actual is this one, the first one, which is 2.7124. So that is our relative error. Then there is what we call percentage error. So this one sometimes is termed as error. Then there is what we call percentage error. Percentage error. So this one is got by multiplying the relative error times 100, expressed as a percentage. So just get the relative error, which is this, the one that we got from up, then times 100, which is relative error was 0.124 out of 2.7124, but times 100%. You express it as a percentage. Yeah, so that's how we get relative error. Then the last one is we can have maximum relative. Maximum relative error. So now to get maximum relative error, what you do is just very simple. We just get maximum relative. Still, this one is like relative, because remember relative, we say that we relate. But what do we relate? We always relate absolute error out of something. So the difference between relative error and maximum relative is that for relative error, we divide absolute out of actual. But for maximum relative, we divide absolute, but instead of using actual, we use approximative. And that's how we do it. Absolute was 0.124, but out of approximative now, which is 2.7. So this is how we do this work. That's the introduction for errors. Those are some of the terminologies that we use in what? In errors. So we can have different numbers. We can have different numbers. So they can give you an exercise and they say for the following, for example, pi, you write the whole of it and then you round off. You round off to two decimal places. Then you calculate the error, calculate the absolute error, and relative error, and percentage error. Meaning that using your calculator, put for me pi, get the answer. The whole of it that you get before rounding off is going to be our actual. So that one, after rounding off, will be approximately, and then you continue like that. Thank you. See you tomorrow. Yeah, as we're joining, as we engage more with the error propagation, those things. Thank you so much for watching. I remain Rashid Elisha Semongo. See you later. Don't forget to subscribe.